Okay, it's right on the hour, so we'll get started. Thank you everyone for joining me. My name is Kristian Doerken. I'm the product manager at Waterloo Hydrogeologic. We're here today to talk about environmental data management and Hydro GeoAnalyst version 9. A couple of housekeeping notes before we get started. We're using GoTo meeting. There's a mute button on the controls, so please make sure your phone or microphone is muted to eliminate any background noise. And we'll have a Q&A session at the end of the presentation. And there's also a chat feature that you can use to ask any questions as the presentation goes on, and I'll be sure to answer them at the end. If you have any questions afterwards, you can also feel free to email sales@Waterloo Hydrogeologic or support. We are recording this webinar, and we'll make the recording available on our YouTube channel. A little bit about Waterloo Hydrogeologic. We've been around for over 35 years, providing industry-leading software to the environmental field. We have clients in over 125 countries, and we provide our software to users from different industries, including government, direct industry, mining, energy, oil and gas, universities and colleges for both research and for learning, and then also to the consultants that serve all of these areas. We have 4 main products that we offer, and we'll be talking today about Hydro GeoAnalyst. So why in the first place would we want data management? What is it useful for? And how do we get the most out of our data? So more traditional, original data management approaches have been sort of a little bit unorganized, without standardization, sometimes have unreliable or inconsistent data quality, and multiple copies of the same information. Before being product manager, I was a consultant for about 15 years. And there were projects where I was sort of the junior staff member on and asked the product manager, should we be using a database to centralize all of our information? And they said, oh, don't worry about it. We're saving time by just doing everything in Excel. And I can remember more than one instance of having to track down all the spreadsheets where all the information was stored and handwritten field notes and try to collate all of that into a consistent format so that I could do more long-term programmatic analyses. And I know I had spent on at least more than one occasion up to a month just wading through programs that were over 10 years old with different staff collecting different pieces of information like water levels or pH readings, and each staff member had their own format. And it was a bit of a nightmare, particularly with things like water levels, where some people would record the depth to water and that was it, and then you'd have to go somewhere else to try and track down the top of casing, and sometimes that changes, the stick up changes. So it can be a bit of a nightmare and you're overwhelmed with data in not a very good format. So an integrated data management solution is a much better and more modernized approach to this problem, and it allows you to use a central database that uses a consistent data structure. So going back to the top of casing analogy or reference point for your water level measurements, if you have a consistent data structure then that always references the same piece of data in the same format, in the same units, then you're going to be storing quality data that you can track over the life of a project. And then this database acts as a sole repository for all of your information related to your projects. So data management, I think I've made a relatively compelling case on why data management is essential. And it's particularly essential for larger projects or programs and organizations that require consistency in their data, quality in their data, repeatability in both how data is collected and also in how it's presented, and also scalability in growing these kinds of projects and managing the information. So things that you would want in a good data management system would be the ability to handle large amounts of data in different formats, be able to track constant changes as your project grows. So you want to be able to change the amount of information or new types of information and assimilate those into your project as the project changes over time. You want to have a proper data structure that's organized and fit for analysis. So you want to be able to set standards based on your site specifics and tailor that data management solution to be able to handle your particular case, and then integrate all your information analysis. So you don't have to use third-party software. You can just use one central data management system to do a lot of your analyses. And this allows you to collaborate and communicate efficiently. So if you have multiple users connecting to the same source of information, that's the one source of the truth, you can use that then to generate different reports for different project stakeholders, including managers, environmental agencies, sometimes non-technical stakeholders as well. And then you also want to be able to allow different degrees of access to your data. So this kind of follows the information management pyramid, where you have data management as the base of your pyramid, and all the tools provide value all the way up into insight. So really what you're looking for is a solution that structures your data, allows your data to flow from collection through to reporting and decision making, and then allows you a variety of these tools that are listed to really get the most out of your data. HGA is our solution for providing you with a solid foundation for data management. It's based on a SQL database, and there's a template structure that comes prepackaged with HGA, although it's fully customizable, so you can create your own data schemas and structure the data in any way you want. There are some limitations in how the data is structured in terms of certain tables are required, and those are kind of made known in the interface. And they largely have to do with interfacing with certain modules, and we'll get to those in the live demo. So HGA sits on top of your SQL database and provides you with a series of modules, each of which has its own purpose in three broad categories, including data management, analysis, interpretation, and collaboration. New in HGA 9, we've added in a new edition. It's a premium edition called HGA Plus that integrates all of the functionality of Aquachem. So the main modules that comprise HGA include the data management modules, the first of which, and probably the most important of which, is the template manager. It allows you to easily customize your data structure, provided you have access in the SQL database. And you can add unlimited tables and fields to your database and structure them in pretty much any way you want. You can also add lists and requirements on each of those fields. The user manager module allows you to control user access, so you can add different levels of control. These are, for the moment, relatively coarse. For now, you have database owner, a standard user that allows you to edit tables, and then also a read-only user that can browse the data but not really change anything. You also have the ability to import a wide variety of data formats and also make use of the electronic data deliverable and quick checker system, which allows third parties to review the data and make sure that it complies with your database structure before it gets integrated into the system. The list and material editors allow you to specify lists of values, so you can convert your database fields into drop-down menus. Some of those are optional, so you can actually add to the list as time progresses. But this provides for consistent and reliable data entry. A good example of this would be forcing users to use perchloroethylene, or maybe just call it PCE rather than perchloroethylene or tetrachloroethylene, because a lot of different constituents have a variety of names and aliases. So this allows you to choose just one, and then that way every time it goes in the database, it's always consistent. And this increases the quality of your data. There's a specific list editor for materials that allows you to specify the geologic structure of your system. And this is useful for well profiles, cross-sections, 3D scenes. And then there's also a module to run QA/QC checks on your lab data. So you can look at blank replicate samples, MSMSDs, dilution factors, and calculate statistics on those and see if they meet your data quality objectives. In terms of analysis and interpretation, HGA provides Query Editor. This is probably one of the most used and most powerful modules in HGA. And this allows you to, with limited knowledge of SQL, produce your own queries through a visual interface. So you can quickly build these queries. And if you're proficient in SQL, you can actually open up the SQL that's produced using the interface and modify it as you need. There's also Well Profile and Cross-Section Editor that allows you to create custom profiles of your various boreholes and well construction details. And then you can interpret cross-sections from that information. There's a map module, which is a lightweight GIS framework that allows you to import GIS data and also make use of the data directly in your HGA database and post that in the map. And last but not least, there is a 3D scene viewer that allows you to build 3D scenes and do 3D plume interpolations as well. And these are dynamic so that you can create 4D plumes in time as well. And I'll show you that in the demo. New to HGA 9, we have introduced plot collections. So you can create query-driven plots based on your data. And the last sort of broad category is the collaboration category. So in here we have modules to facilitate the flow of data and information and help in reporting. The first of which is the mobile EDD workflow, which allows you to create templates for data collection, push those to a web server, which can then be downloaded by any mobile device. You can work offline, collect your data, submit those to your web server, and then that acts as a staging area for you to verify the data before it gets integrated into HGA. There's also an event planner that allows you to plan out sampling events and other activities associated with data collection. You can create templates from that and then share those as Outlook calendar invites so that you have pretty much the entire sample plan built relatively quickly and shareable with your stakeholders, including your field staff or third-party labs. You can also print a lot of information directly to Office documents, so you can build templates that are customizable and then print any information you want from the HGA database into those documents. So here are some examples from one of our clients and some well profiles, 3D scenes, and some plots. Online sharing, there's also the ability to create a structured website or web pages, and you can publish static snapshots of your data that are interactive, and you can choose where these land. So if you have your own website and you have control over who has access to it, you can create customized versions of your website, and you could have multiple versions of that. So you may have one for internal stakeholders versus external stakeholders on your projects. And last but not least, we also have links to external applications. So one of our other applications is Aquifer Test. So you can create, if you're scraping your data from water level loggers, you can import those into your HGA database and then create tests relatively quickly using the link to Aquifer Test. And then there's also links to Power BI. I know quite a few clients are using Power BI extensively with HGA to create dashboards for all of their information. Very new to HGA 9, we've introduced a new edition called HGA Plus, which includes a large number of new modules. The first of which is a series of modules that allow you to manage and interact with samples. So you can create lists of samples and then parameters. These are all query-driven or can be static as well. There's also mechanisms to import water quality standards and use those as reporting tools. There's over 30 built-in geochemical and statistical functions that are listed here and also on our website that allow you to calculate very common geochemical parameters as well as dynamic unit conversion. The plot module in HGA Plus is greatly extended to make use of the sample modules. The plots here are dynamic and interactive. And there's also additional geochemical plots. So instead of, I believe there's 10 plot types in HGA standard, there's 19 in HGA Plus. And last but certainly not least, we've introduced a new R console, which allows you to build R scripts directly in HGA. And there's an interface for connecting various sources of information into your R script. So the new features that we've introduced into HGA 9, the biggest of which is the HGA Plus modules. So we, again, have the sample modules, the dynamic plots, and our console. Those are probably the biggest game changers for HGA Plus. There's the plot module for standard HGA. We've made some improvements to the list editor so that you can auto-generate fields based on specified fields. And I know that'll save a lot of time for our existing users. It has been a frequently asked for feature. And we have some other enhancements. We've updated SQL Server support. So we now support up to SQL Server 19, made some improvements to report generation and the data import tool. And there's a complete list of enhancements available at our website at the HGA README page, which you can access also through the HGA Start page. So now it's time for the demo. Let me switch over to HGA. And here we are. So when you first open HGA in a project, The first thing you'll typically see is the station list. So this provides information for all of your sample collection points, and it has spatial information. This also has a table here. The table is filterable. So if we want to look at, say, all of our monitoring wells, you can quickly type in values and filter them. If you have a pick list, you can also use the pick list to filter your information. Any of the filters can be cleared, so you can rapidly access your data. Also, all the information is stored in a project tree, so it's easily accessible from here, and we'll be using this feature in the demo a fair bit. Information related to each of your stations is categorized in the station data table. So if you have a station right here, you can quickly find out information specific to that station. And then we'll go back to our monitoring wells here. And you can collect or quickly review information of different categories. So say water levels for a given station as they change over time, or if you've collected any samples, you can also see that. And if we go and change what station group we're looking at, you can create groups of stations based on either static lists or lists based on certain search criteria from a query. If we go in and look at our, say, boreholes with plot data, we can look at geologic information. So if we have geologic information, you can also add in other information for hydrogeologic interpretations or modeling layers. If we've got a well, you can track that, as well as geophysics. So you can import a variety of different data structures, and these are all included in the basic template. The list editor allows you then to create these lists. This list here is a list of station types, and if we have newly imported information, you'll note that previously we didn't have a soil boring in here. This is new information in the existing database. We can add that, and then that becomes added to our list quite quickly. So then now that's part of our new list, our updated list. The well profile then allows you to create a variety of different profiles for wells, whether it's well completion or construction of your casing information, and also maybe some of your geophysical data. You can add various components, and each of these is customizable, and you can also create completed reports from this. We also have 3D scenes, and I think I'm getting a little ahead of myself, so I'll skip back to the map module and cross-section editor. So in terms of 2D maps, you can create 2D maps that have connections to your data. This is a query of all our boreholes. You can post data in mini tables and have that information listed for relevant data points. And then we can also create cross-sections of our information. So cross-sections come in 3 different varieties. We have the geologic interpretation, which is the basic interpretation. You may need a hydrogeologic interpretation that's maybe more simplified and targeted towards building a groundwater model, say in Visual ModFlow, or your model layers as well. And you can switch between your cross sections, and these are noted on an inset map right here that's linked to the parent map. So going back to our 3D module, you can build 3D plumes based on data in 3 dimensions and in time, and interpolate that into solid plumes, and then build videos of the plumes over time. And those can be exported to AVI files for sharing with clients that don't have HGA. All of these are customizable. You can import things like surfaces. You can turn cross sections on or off, and then also build reports based on that. So moving on to the HGA Plus modules, we have new in HGA 9 with the HGA Plus, the sample list, which is kind of akin to the station list. It moves down 1 level and provides you lists of all your samples. Again, like any other table, these are filterable, and you can quickly look at any of the information. And then for each sample, if you've selected a sample, you can also look at the parameters here. And let me switch to a station group that has more information in it. So if we look here, we've got this particular sample collected on January 31st, 2004. We have a variety of parameters that were collected, and we report results for those. So you can quickly look through each sample and see the results. And we also calculate a variety of common geochemical or statistical analyses based on the current sample. There's around 25-ish, and these can be turned on or off in the project settings. So if you go in the project properties, there's a tab here for functions and allows you to turn these on or off, or change maybe the label or some units. So going back to the measured parameters, you may notice that some of these are highlighted. These are highlighted to show whether or not there's an exceedance of a given standard, which brings us to our water quality standards. So you can import or enter in and add various water quality standards. So there's 3 in this particular project. And you'll notice each one of these has a different color, from yellow to orange to red. And these can be turned on or off. So if you notice here and you're familiar with red being associated with, for instance, the EPA MCL, then you know that you've exceeded the MCL, in this case, for this sample for lithium. So you can quickly see exceedances at a glance. And as you become familiar with which the active standards are, you can see which exceedances occur in each sample. So we can actually turn these on or off very quickly. So if I turn this to false, hit save, go back to the sample list and hit refresh, then it's turned off and we can quickly turn it back on again. And if we're only interested in a handful of data, then what we can do is look at a different variety of parameter groups. So built in, there are some parameter groups like cations that are generated automatically based on the valence of your parameter. We also can create custom ones like organic constituents. So what we may want to do is go into the parameter group editor, which is also on the main toolbar here. And you could create a new parameter group. So for instance, if we were interested in tracking BTEX, which is benzene, toluene, ethylbenzene, what we can do is create a new parameter group. We'll call it BTEX. And then we'll add in the individual constituents of BTEX and click Save. And if we go back to the sample list, we can go into this dropdown and BTEX is there, and you can filter to just the BTEX constituents. So you can quickly build different groups of parameters to see constituents of concern by category very, very quickly. This also brings us to our sample report. So what you can do is if we've built a series of station groups, say we have a sample set for all of our major ion collection, and we want to look at the major ions, we can build a report here. So this has all of our major ions, and say we're also interested in organic constituents. And again, we'll add in BTEX, and if I hit refresh, BTEX will be there. So we can add those in as well. If we don't like our list, we can clear it. So we'll go back and rebuild this. So we have our major ions again and BTEX. There we go. We've got then a report here that we can build, and we can also choose some statistics. So here we have a variety of different common statistical values from counts of samples, numbers of exceedances, and then min, max, median, and percentile range. And then you can also choose to compare these to one or more active water quality standards. So let's select all of our parameters. If you hit the play button, it'll generate a report for you. It's kind of a cross tab that includes all of your parameters, your standards that are active, and then each of your reported samples along with any exceedances that get highlighted, and then your statistics on the right. All of these can be exported to Excel. So if you need to do a little bit of extra formatting, you can quickly produce reports or appendices very, very quickly. So in a few button clicks, you can save these reports and then rerun them. And these are all tied to your station groups or sample sets. This brings me to the sample sets. So what you can do is actually create sample sets using the query builder. And what you would do, I've actually already just created one, but I'll create a new one here. I'm not going to save these. So if I want to create a new sample set, you select the query type, and we'll call this calcium greater than 5 milligrams per liter in, say, 2008. So we can hit save there. And what you do is you can add in now parameter conditions. So this allows you to build your query very, very quickly, and you can pick up any parameter value. And so maybe we'll go back to our major ions or cations. We'll choose calcium, and you can choose any parameter very quickly. And then say we just want 5 milligrams per liter. And then we want to choose samples that were collected in the year 2008. So if we go to our sample parameters, we have our sample date here. This list is also filterable. So you can see that you can find things very quickly. We'll choose our sample date, and we'll select 2008, January 1st. And we'll also select samples before January 1st, 2009. And since these are linked together, we need to join them using an AND statement. And now we have our query. We can save that then. And this sample set will get saved into the project tree here for future use. And we can hit save and then run this. So this will produce our sample list here. Now we have a subset of our samples that meet those conditions. And if we click back and forth, we can easily access this list. So if I go to the all major ions, and this is a little bit slow because I have a bunch of windows open that all are linked to the sample set. So you want to be a little bit judicious if you have larger projects in having various windows open. But then we can go back to our initial sample set. So this allows you to build your reports relatively quickly. And you'll notice that then we could just quickly run this report on our calcium samples with values greater than 5 milligrams per liter in 2008. Just change the search criteria, maybe edit this. Maybe we would just quickly want to make this a 2009. Hit OK. And then we could just change the dates. Hit save. And now in less than a minute, you can create a brand new report for the following year. So if you're doing periodic reports, quarterly reports, or monthly reports, you can quickly update these values and create reports in less than a minute. And they're pretty much client ready and ready to go. So next we have our plots. And what you can do is create plot collections. So what a plot collection is a series of plots. You can add in a variety of different plots. So if we want to add in a new box and whisker plot, we can do that. And these are for HGA Plus. These are tied into your sample sets or station groups. And they can even be the active station or active samples. So this makes the plots dynamic. For the standard version of HGA, these are only tied into queries. And so you'll just see the query drop down here if you have the standard version of HGA. If we go back to the beginning here, we'll look at the box and whisker. And you can quickly scroll through a variety of plots. You can see a list of the plots within a particular plot collection. And you can also change the layout of the plot collection. So if we wanted to create a tabulated version with plots one on top of the other or side by side, you can add them into columns and format them that way. These can all be exported to a PowerPoint presentation. So we'll add that in. We'll just say standard report. And there's a couple of pre-configured templates that you can use. And you can either export just a single plot or the whole plot collection. And if you have multiple plots in your layout, you can either keep that layout or just override it and do one image per plot. So we'll do one image per page. And since this is a portrait layout, we'll do that and export it out. And now I've got a PowerPoint presentation that has all my plots in it with a nice professional looking layout. And again, that can happen in a matter of seconds. So because these can be tied to sample sets in HGA Plus, you can quickly change from, say, the first one we built to the second and rerun your report. So in a matter of 2 minutes, you can run a quarterly report, which is quite powerful. So for the HGA plots, there's a variety of different plots that you can use, from detection summary to Duroff plots. Probably the most commonly used will be things like the Piper plot and stiff plots, but there's quite a variety of different plots. Also, something that's quite powerful that's unique to HGA Plus is if you have, we go back to, I'll open up this plot collection here. We go to our sodium versus chloride. You can see the base data is reported for chloride in milligrams per liter, and for sodium also in milligrams per liter. It's often useful to compare constituents one to the other. A good basis for doing that is in units of moles per liter. So directly in HGA Plus, what you can do is go to the axis unit and just change the units. And in this case, we'll want millimoles per liter. And we can hit apply. And then do the same for the y-axis. And now we have a standard basis for comparison between sodium and chloride. And you can also add in a line of comparison. So if we want a one-to-one line to see if sodium is tracking versus chloride, you can just put in a line of slope 1. And there it is. You can see very quickly how sodium compares to chloride. So in a few button clicks, you can do quick unit conversions for fairly common constituents. This adds quite a bit of utility to the plots. We also have dynamic plots in HGA Plus. If you have any of your plots tied to a sample set or a station group through HGA Plus, then what you can do is actually click on your samples. And if I have my sample picker here, what you can do then is click on any of the data points and have the charts update. So I've got this stiff diagram is actually tied to the current sample, and it gets highlighted on the Piper plot, the stiff plot updates, and the sample picker updates. And the link is two-way. And with the ability to dock our windows, what we can do is look at a plot and then also our sample list. So we go back to our sample list. So then you can quickly see everything is tied one to the other in rapid succession. And if we change our sample set, so if we look at calcium in 2008 versus calcium in 2009, then the plots update based on that, which again is quite powerful. And another thing about the sample sets, if I go to build a new sample set, so I'll create a new dynamic sample set, save my changes. What I can do is also tie these to exceedances, and these can then be directly tied to the water quality standards. So say I want to look at exceedances of benzene. So then what I can do is create a sample set. Again, what I'll do is instead of tracking a condition based on a parameter value, I'm going to track it based on a standard being exceeded. I could choose any parameter, or I could choose, say, benzene. Oops. Need to switch over to my analyzed. And again, I can choose any active standard, or I can choose a particular standard of interest. So I'll choose any active standard. I can hit save and execute my query. I'll get returned over to the sample list. And now I can do a plot based on those exceedances. And again, these can be saved in the sample sets. These can be grouped into folders. So if I want to do quarterly reports, then I can stick these in a folder. And then these are easily organized and accessible. Okay, another thing you may notice, actually what I'll do before I get there, is I'm gonna import some samples as well. So we have a new sample importer that's for HGA Plus. Let's see, there we go. I'll import some water quality data. So you can import data in one of two formats if you have a flat structure with one analysis per row, or if it's been pivoted and you have samples as rows or columns, you can adjust the import format for that. This one is a flat structure with one analysis per row. If you import data of the same structure over and over again, you can create import settings and apply those. So these will allow us to preserve our mappings and recreate those consistently. You can also add in constant values. So in this case, say we have an import batch, we want to keep track of when we imported it. Just add in a number here. And then these values are the fields in the HGA database versus the column headings in our source data. New to HGA 9 as well, you can also import format. This is particularly useful for dates. So if you have a sample date and you're doing day, month, year, or month, day, year, you can type in whichever value you'd like and it'll parse it that way. So hit next on that. And at the validation step, you'll get any warnings if they occur. I've already imported this data, so it's going to ask me if I want to update or reject this new data. I'm just going to update it. Hit continue. And now we've got a list of all our parameters. So if these are the parameters in the source data, and these are the parameters in the project. And if there's missing parameters in the project, say you're importing new data and you haven't analyzed aluminum yet, you could add that value in. If, say, it's AL in the source data, but aluminum in your project, you can tie those two together and link them. And there's also a sort of parent chemicals list that you can store outside of the database and use that to collaborate with colleagues within your organization and create a parent chemicals list that can be a larger library of all the constituents that your entire organization tracks. So again, you can have consistency across the entire organization if you store that in a central location and keep it there. So you can just add any of these if you need, and then we'll hit cancel because we have proper mappings for everything. And the units are tracked as well in a similar fashion. And then you'll get a preview of the sample and the sample analysis tables. And at this step is where you can import your mappings if you're creating a new import structure. So then I'll import the data. And then once you hit OK, it's integrated into your database. So fairly quickly, you can assimilate data into the database structure. And you'll notice here, I had already imported these data, but they have a default symbol. You can actually go into the symbol editor. So if I go here into the plot collection and go to the symbol editor page, I can create symbol sets based on, say, the station type or the station name or just the water quality station. So if I go to maybe station type, I could hit apply. And again, since I have a few plot collections open, it'll take a minute to update. But then now I've got, these are all observation wells. If I go back to the water quality stations and again hit apply, then you'll notice my values are updated. You can create new parameter-based symbol groups. So you can basically create values based on any different station type, say one per name, or categories of elevations, types, maybe based on sample date. So there's a whole variety of different ways you can categorize these symbols. The sky's the limit, really, based on your data structure and your imagination. Last but not least, we have the new R console. So I'll close this dynamic plot and have the full window. And what this allows you to do is connect directly to your database, either directly to a table within the database, to parameter data, or to queries that you've built within your project. So in this case, I'll just show you a quick example of how you would build a variable in R. So you just double click anywhere in one of these three interfaces and come up with a variable name. So we could do station name and then do station.name. And then you can pull information from any of your station groups or a specific station if you'd like as well. So you could use, say I want MW3. I could click that, hit OK. And then this would pull information from station 3. Or actually, we'll go in and I'll show you what all the stations look like. Hit OK. And then we could print the name. So if I run that, oops. Sorry, I think that has to be lowercase. There we go. We now have a list of all our names stored in a variable called name. And if you need to use this R script in maybe RStudio or a different IDE, you can run the parse command. And this will then convert the data into something that RStudio can understand. There's a couple of different subtleties between the HGA version of R and the standard version of R, and those are documented in the help section of the latest manual. But it's almost entirely the same. The main difference is in how you connect to the data, and then also line continuations are slightly different as well. I'll show you a couple of sample scripts that we've got in the demo project as well, and just to see how they run. So I'll uncomment the key commands that link you to the data. The tutorial itself runs you through how to build these particular commands. I'll just run the plot command. And so what this particular script does is it generates a table of values of your major ions for a particular station over time, calculates some basic statistics on those, and then does a Mann-Kendall analysis, and then performs a correlation matrix. All of that gets dumped out to an Excel file. So if I open that up, we then have our raw data then dumped out into Excel. So then you could work on it a little bit and get it ready for a report. Or there's also in R a great plotting module or library called ggplot that allows you to create various plots. These are different versions of a correlation matrix. So you can actually see the correlation of various ions to each other. It's quite powerful. And then I'll open up the third script. And this one's already been uncommented, so I should be able to run it right away. And this one is pulling information from our station tables. And what it does is it'll actually generate a map using a library called Leaflet. So this actually creates a local map for you. And I believe you can actually use Leaflet with a little bit of extra work and publish these directly to a website. So you can create kind of dynamic plots that you can customize. These can zoom in. You can actually bubble these together, build insets and legends, and then also symbology. So it's quite powerful what you can do with Leaflet. I know it's used a lot in academia to build some pretty amazing graphs. And then there's also some plots that get generated in this particular script as well. So you can build custom plots as well based on your data. And these are quite powerful. R has a lot of great statistical tools in it, and it's being used more and more all the time. I believe there's, at last count, around 15,000 odd libraries, and they're all well documented. So it's pretty much limitless what you could do with the R console. And with that, that's pretty much the end of the demonstration. So I'll flip back to the PowerPoint presentation, and thank you very much for your time. I know your schedules are quite busy, so I appreciate you taking the time out to spend time with me. And if you have any questions, feel free to reach out, and thanks once again.